lesson 4-5, linear regression. We're going to still work more with scatter plots and analyzing data. Calculator can find the line that most closely approximates data in a scatter plot called best fit line. Now you could still do this without a graphing calculator by using the points on there, but if you want the most accurate of line that you could possibly make, a calculator will do that job for you. Linear regression is one algorithm used to find a precise line of fit for a set of data. Calculators may also be used to compute a number R called the correlation coefficient. When you use your calculator, there's going to be a coefficient labeled R, and that's going to tell you how accurate it would be. This measure shows how well the data are modeled by a linear equation. It will tell you if a correlation is positive or negative and how closely then the equation is modeling the data. So the closer the correlation coefficient, so the closer R is to 1 or -1, the more closely the equation models the data. Now we have different kinds of correlation. We got weak correlation, moderate correlation, and strong correlation. Weak correlation means they're just all scattered. And you can see the R is 0.02. So if you think of that as a percent, that's like 2%. So it's not real strong. Moderate would be, there's a pattern there. They are getting closer together. So this is roughly 72.72 or like 72%. Strong correlation, you're slightly packed together. You can see a pattern. This one, R is a negative 0.97. So that's close to a -1. If you think of 1 and -1, think of that close to 100. That's like 100%. So negative 0.97 is like 97%. Closest to -1 and 1 is what you want, the strongest correlation. The table below shows a rule of thumb for determining how well the equation models the data based on the correlation coefficient. So in general, if the R correlation coefficient is greater than or equal to 0.8, that's strong. If it's between 0.5 and 0.8, that's moderate. And if it's less than 0.5, it's weak. So think of more than 80% strong, between 50 and 80, moderate, less than 50% is weak. Example 1, the table shows Jackie Robinson's total hits during each season of his major league career. Use a graphing calculator to write an equation for the best fit line for the data, then find and interpret the correlation coefficients. So how are we going to do this? Step 1, we're going to enter the data into our calculators. So before we do this, we have to make sure we turn the diagnostic setting on our calculator. To do that, I'm going to grab my calculator here. You're going to go to the catalog, and down below here where 0, it says catalog above it, so I'm going to hit second 0, and that turns the catalog on. And I need to go down to D and scroll down to D until it says diagnostic on. So diagnostic on, I hit enter and then hit enter again. Once you see diagnostic on here, then you're good. Our next step, you're going to enter the data by pressing stat and selecting the edit option. And we're going to let the year 1947 represent the year 0. And then we're just going to keep going down for your list 1. And then list 2, we're going to put the hits. If I go back to here, so we can see what our numbers would be. So I'm going to hit stat, go to edit, and I need to clear what I have in here. So to clear it, just go up to L1, hit clear, enter, go to L2, go up, hit clear, and then hit enter. So L1, 1947, we're going to use as year 0, and then hit enter after every number. So that's 0, 48 would be 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 years that we're using. Now the hits, we're going to put those exact numbers in there. So 175, 170, 203, 140, 185, 157, 159, 120, 81, 98. Now that we have all of our data entered in, now I'm going to go to our next slide. So here we're going to perform the regression. So to perform the regression, you're going to hit the stat button again and select calculate option. And we're going to scroll down to linear regression, which will be AX plus B, and then press enter. And we just need to make sure that L1 and L2 are listed, and then you select calculate. So now if I grab my calculator, I hit stat, we go to calculate, linear regression, the AX plus B, hit enter, and hit enter a second time. Let me go back to that. Let me clear this and then hit stat, calculate, number 4. Now hit enter. Let me check my stats. So it says mismatch, so I got to check what I have in here. So stats, go to edit. See, I have an extra number in here, so I need to figure out which number does not belong in there. So let's go back to the table. So we got 1, 2, 3, 4, 5, 6. So 10. So I need to have another number. So if I go back to my y's, the very bottom, I need a 9 here. And then if I go to stats, calculate number 4, hit enter, then it gives me my equation, which will give us as negative 10.3, it would do it to the nearest hundredth, so negative 10.32 x plus 195.21. So you perform that. Here you can see what you should have gotten on your calculator. Write the equation of the regression by rounding A and B on the screen. So your A is your slope, your y-intercept is your B, and your correlation coefficient. You can see that this says R is negative 0.8. So that would be a strong, so that's about 80%, so that's close to what we would want on it. So if I go back to my calculator, I'm not sure, yeah, I didn't see mine on here. So if I go back to second catalog, go down to diagnostic on, I want to turn that, make sure that's on. If you don't see yours on there, there. So now if I hit stat, calculate number 4, you'll now see it. So if you don't see the R coefficient in there, it's because the diagnostic is not turned on. Correlation coefficient is about negative 0.8022, which means that the equation models got on well. Its negative value means that as the years since 1947 increase, the total number of hits that he has decreases. So he's been decreasing over the years of his career. Next, the slope of the regression equation means that the number of hits decreased by about 10 per year. If it was a positive 10.3, then you would say that he increased by 10 per year. And the y-intercept just shows that he had 195 hits in 1947. Next example, the table shows the number of international tourists that arrived in Europe from 2005 to 2014. The number of years since 2005. Use a graphic vector to write an equation for the strip line for the data, and then find and interpret the correlation coefficient, round to the nearest hundredth, which just means 2 decimal places. So I'm going to grab my calculator again. I'm going to hit stat, hit edit, and we need 1, 2, 3, 4, 5, 6, 7, 8, 9 years, which I have those in here, so 0 to 9. So in general, when these are dealing with years, you'd always want to start with 0. Now I want to clear this one, so clear, hit enter, and then I type in those numbers. So 453, 463.9, 485.4, 487.6. Then we have 461.7, 488.9, 516.1, 534.4, 566.4, 581.8. You'll notice that I have one less here, so I need to put, actually no, it matches up here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 years. So I have 10 years here. I'm going to hit the stat button, go to correlates, or calculates, number 4, hit enter, and you can see we have 0.92. So that is very good for that one. Need to come up with our equation. So our equation, the nearest hundredths are 2 decimal places, so we would have y equals 13.54 x plus, and our b is 442.98. So that would be our equation for a line of best fit on that one. Then it says, and find the correlation coefficient. So we said R was 0.92. Double check that, 0.92. So interpret the correlation. This would be a strong correlation. So as the years have increased, so has the international tourist numbers have increased as well. Next, the table shows the average annual tuition for the most populous states in 2014. You can see the rank here and the total choice. What we want to do is use a graphing calculator to write an equation for the best fit line of data and then round to the nearest hundredth. We'll find the correlation coefficients, the nearest hundredth, and what we find doesn't model the data very well. So I'm going to go back to table so I can enter my points in there. Hit stat, edit, and the rank. We're gonna edit these. So we're gonna hit clear, hit enter. Over here, hit clear, hit enter. Okay, now let's type in here. So we got 1 through 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go over, we got 59.4, 64.8, 70.7. We got 45.4 and 51.8. The next for 6, we got 48.8, 50.7, 63.5, 59, 44.4. And then we're going to hit stat again, go to calculate, number 4, hit enter. Here we have our equation. You notice that our R is negative 0.41, which means that is not a very strong correlation for that one. So if we were to write the equation, let's go back to here. So our equation would be y equals negative 1.2 x plus 62.47. Our correlation coefficient, the R was equal to a negative 0.41. Based on what we have, doesn't model it well, no, it does not model well because this is a week is below 0.5. Next, the table shows U.S. desktop online sales on Cyber Monday since 2009. Estimate the Cyber Monday sales in 2025. So the first thing we're going to do is enter the data into the table. We're going to let 2009 be represented by 0. So grab our calculator. I'm going to put that over here so I can see the whole table. Hit stat, edit, going to clear everything. Okay, we start with 0, 1, 2, 3, 4, 5, 6, 7, and 8. And then we have 887, 1028, 1251, 1465, 1735, 2038, 2280, and 2671. Hit stat again, go to calculates, number 4, enter. We have a mix match, so I need to go back to stat, hit edit. I skipped a number, always. So we got 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7. I had an extra one over here. Delete that. So now I go stat, calculate, number 4, enter. Okay, so our equation is going to be 2.5451 x plus 778.58. The correlation coefficient is 0.99, so that is very good. Let's write that down here. So we did all that. We're actually going to graph this one. So we need to go to our calculator again. Let's go to, just make sure our stat plot is turned on. So hit second, y equals. It is turned on, mine's on scatter plot, so I'm good here. So I hit zoom. Number 9 is zoom stats. So if you go down to number 9, or just hit number 9, zoom stats. I have my graph, so that's what it looks like on the screen. Now if you want to do the regression, we did the regression already on that. So to do that, again, go back to my calculator, just going to hit stat, calculate, number 4, enter. We're going to have y equals 254.51 x plus 778.58. So that would be our regression, our equation line. And now it says we need to put that line. So we're going to graph that, put the line in there. So to do that, you're going to hit the y equals. I'm going to grab my calculator, move this over here. So we're going to go to y equals. I'm going to clear what I have in here. I'm going to hit vars. We need to go to statistics, number 5. We need to go to EQ and number 1. And then press graph. And there you can see our line goes through our points, our line of best fit. You can just put the equation that we just had in there. Now we can use the graph to predict the 2025 Cyber Monday sales. Change the viewing window to include the X value to be evaluated, 16. Also increase the Y max to accommodate the increasing Y values. Then you press second, calculate, enter, 16, enter to find out when after 16 you should get 4,851. So let's do that right now. So the first thing we need to do is change just see what our Windows settings are. Windows settings, negative. The X max, we have to increase that one. So I'm going to make this 25. So we can at least see, not 25, let's I'm going to make this 30. And then the X scale, I'm just going to count by fives. The minimum, Y minimum, we'll just do 0 as the minimum. The maximum, I'm just gonna make it 4,000. The scale, let's count by 250. And let's see what that looks like there. And then now if we hit second, calculate or trace, calculate, we want to find the value. So number 1, when X is 16, we want to find out what Y is. That would give us 4,850.77. So that's how you get the 4,851. We're going to do that same thing, but we need to find out the amount in 2025. So to find out that in 2025, it would be years since 2009. So how many years from 2009 is 2025? If you did 2025 minus 2009, that would be 16 years. So 16 years after that, which would give you 4,850. If we were around it, 4,850. But remember, these numbers are in the millions. So this would be let's see. Yeah, so this would be 4,851,000,000. So that's how the estimated sales for Cyber Monday would be in that year. Next, the table shows the number of daily users on a social media sites in various years. Use linear regression to estimate the number of daily users in millions on the site in 2030. So the first thing we'll need to do is enter this data into our calculator. So you hit Stat, Edit. We're just going to clear everything here. So we'll have 2011. This would be we'll use 0 for 2011. So 0. We got 1, 2, 3, and 4. And then going over, we got 372, 526, 665, 802, 936. And then we hit Stats. Let's go to Calculate. Number 4. Hit Enter. Here we have our equation. We're going to put that into our y equals. So I'm just going to clear this. So I hit vars. Number 5, go to EQ. Number 1. That puts our equation in there. Then we can hit graph. Then second, trace. 2030 would be how many more years? We go to number 1. We're going to type in 19 because from 2011 to 2030 is 19 years. Hit enter and you get 3,047. Remember, this is in the millions, so the choice that would give us would be choice C. last part is looking at residuals. What do they mean by residuals? When finding a best fit line, not all data will lie on the line. The difference between an observed y value and a predicted y value on a regression line is called a residual. So it's really how far away is a point from the line. When residuals are plotted on a scatter plot, they can help assess how well the best fit line describes the data. If there is no pattern in the residual plot, and the residuals are close to the line y equals 0 relative to the scale of the original data, then the best fit line is a good fit. So our example, the scatter plot shows the average price in dollars of a 10-person Thanksgiving dinner Y for several recent years, X, with a line of fit for the data. Use the scatter plot and the residual plot to determine and interpret the strength and direction of the correlation. If we look at this, we can see in our equation here, we have a positive slope of 1.5. So it is increasing. You can see that the points are very close to the line. So we would say that that's a strong correlation, and it's a positive correlation because it's going up. So our next slide says the line of fit has a positive slope, which indicates a positive correlation between the variables. This means that the average price of a 10-person Thanksgiving dinner has been increasing as the number of years increases. The residuals appear to be randomly scattered with no pattern. So if you look at the second one, here's the residual one. They seem to be scattered and there's no pattern. Additionally, the residuals are close to the line y equals 0, which indicates the line of fit models the data well. This implies a strong correlation between the variables. So there is a strong positive correlation between the number of years and the price of a 10-person Thanksgiving dinner. That is our lesson today on linear regression.